We write the related decomposition equality, which is 1 over x squared plus 2 square is equal to, since you have x as a multiplication, a over x. Since you have x squared plus 2, you should have bx plus c divided by x squared plus 2. Since the power of this expression is 2, dx plus e divided by x squared plus 2 square. Okay, so in this case 1 is equal to, if you make denominators equal to each other, the coefficient of x to the power 4 becomes a plus b. The coefficient of x cubed is c, and the coefficient of x squared is 2a plus b plus d. The coefficient of x is c plus e, and as a constant we have a. Okay, since we only have 1 on the left hand side of the equality, a must be 1 and all other coefficients must be 0. Okay, they are all 0. So in this case a is 1, as I told you, b is minus 1, c is 0, d is minus 1, e is 0. Okay, a, b, c, d, e. Okay, so we have all coefficients. Let's rewrite the integral. Since we have a over x, a is 1, dx over x is the first term of the integral. We have bx plus c, b is minus 1, c is 0, so we have minus x dx divided by x squared plus 2. Okay, let's look at the third term, dx plus e is 0, d is minus 1, so we have x dx divided by x squared plus 2 square. Okay, if you use substitution rule and say u is equal to x squared plus 2 for these two integrals, you will easily find the solutions, as of course the first one becomes ln x. You have derivative of denominator in numerator, derivative of denominator 2x, you have 2x in numerator. This is why the answer of this integral becomes ln of denominator. So the answer is 1 over 2 ln of denominator. And if you apply substitution rule to the third integral, you have minus plus 1 over 2x squared plus 2, and of course a constant c. If you have a factor ax plus b in denominator, you should write a over ax, a constant over ax plus b for the partial fraction decomposition. If you have ax plus b to the power n in denominator as a factor, the partial fraction decomposition becomes a1 over ax plus b, a2 over ax plus b square, and you continue to write all the summations to get the power n, an divided by x plus b to the power n. If you have ax squared plus bx plus c in denominator, so the partial decomposition of this expression is ax plus b divided by ax squared plus bx plus c. And finally, if you have something like this, which is the most complicated expression, you may have ax squared plus bx plus c to the power n. In this case, you write a1x plus b1 divided by this factor, and you continue to write all these coefficients to have all to obtain all these a1, b1, a2, b2 coefficients. The aim here is to find all these coefficients. When you find these coefficients, when you find a partial decomposition for the given integrand, you will easily find the solution of the integral. Now, as a second case, when the degree of the numerator is bigger than the degree of the denominator, we do long division. It is another kind of problems when we talk about integrals of rational functions. So, how do we do long division? How do we do long division? Let's write x to the power 4 minus 5x cubed plus 6x squared minus 18 divided by x cubed minus 3x squared. I do the long division, okay, you multiply by x, so you have, and I divide by minus x to the power 4 minus plus, sorry, let's say this is plus 3x cubed, okay, so this is subtraction, and finally you have minus x cubed, 2x cubed plus 6x squared minus 18. And if you continue, you have minus 18. So this rational function becomes this one. Instead of this one, I write x minus 2 from here, x minus 2, okay, minus 18 divided by x cubed minus 3x dx. Okay, it is the modified version of the first integral. I think it's now more easier to integrate this function. So what is the result? As you see, it's very easy to integrate the first one. What about the second one? As you see, the degree of numerator is smaller than the degree of denominator in the second expression, so we have to focus on the second expression. Actually, we have to find the decomposition for the function. So in this case, to find the decomposition, we have to write the equality 18 divided by x. If we take the parentheses of x squared, we have x minus 3, okay, so we have to find the decomposition for this rational function, a over x plus b over x squared plus c over x minus 3. Okay, if you make denominators equal to each other, you will find ABC as a is minus 2, b is minus 6, c is 2. Okay, so we have all coefficients now. I think we are ready to integrate the function. So let me write down the integral. The first integral becomes x minus 2. Okay, instead of 18 over x squared times x minus 3 or x cubed minus 3x squared, we have this summation, which is minus 2, minus becomes plus 2 over x, this one, b is minus 6, minus plus 6x squared, and c is 2, it becomes minus 2 divided by x minus 3. dx. Okay, very easy question. So we have x squared over 2 minus 2x plus 2 ln x. Okay, third one. The fourth one is minus 6 over x using properties of integral, and the fifth one is minus 2 ln x minus 3 plus c, since it is indefinite integral. Another question: the degree of numerator is bigger than the degree of denominator, so we do long division again. 2 plus x to the power 4 divided by x cubed plus 9x. So you have x to the power 4 plus 9x square. If you do this computation, you have 2 minus 9x square. So let's say this is a. Okay, let's say this is a. A becomes, in this case, if you do the long division, x plus 2 minus 9x square divided by x cubed plus 9x. Okay, so if you look at the second term of the function, you see that the degree of numerator is smaller than the degree of denominator. In this case, we have to find a decomposition for the second part. So how to find a decomposition for the second part? Let's call second part as b. Let's call this part as b. So b is equal to, we have, so it's possible to take the parenthesis of x denominator. This is y. So let me rewrite denominator here. The parenthesis of x, we have x squared plus 9. Okay, so this is c over x plus dx plus e divided by x squared plus 9, using the properties of decomposition of partial fractions. The aim is to find c, d, and e. If you make denominators equal to each other, you will find all these coefficients. C is equal to 2 over 9. D is equal to minus 83 divided by 9. And finally, E is equal to 0. Okay. Now we are ready to solve this integral. This integral is equal to the first term, x, plus b. Instead of b, I have this expression, plus, instead of c, we have 2 over 9x, plus, look at the coefficients, a is 0, so we don't have this expression, and d is minus something, so we have minus 83 divided by 9 times x squared plus 9 dx. So this is the final version of the integral. I think it's very easy to solve this integral. So we have x squared plus 2 plus 2 over 9 ln x minus 83 divided by 18 ln x squared plus 9, and finally we have a constant. If you multiply numerator by 2 and you divide by 2, you see that you have derivative of denominator in numerator derivative, and if you take this coefficient out in front of the expression, you see that you have derivative of x squared plus 9 in numerator, which is 2x. So the result is ln of denominator, in this case ln of x squared plus 9. Another example, if you first look at this question, it does not seem that you have a rational, you have a polynomial, or you may compare the coefficients or the powers, so it's not so obvious. So it is good to first substitute the integral, use substitution rule for the integral. That is, let's say t is equal to get rid of all these root functions. Let's say t is equal to u to the power 6. Okay, so dt becomes 6u to the power 5 du. So in this case, the integral becomes, instead of dt, we have 6u to the power 5 du. Instead of the square root, we have u cube. Instead of the cube root, we have u square. So it's possible to divide each term by u square. Then we have 6. If you divide u square, you have u cube divided by 1 plus u plus 1 du. So it's all. As you see, degree of numerator is bigger than degree of denominator. If you do polynomial division, you will get this expression, u square minus u plus 1 minus 1 over u plus 1 du. Okay, and finally it's very easy to integrate this function, the parentheses of 6. We have u cube divided by 3 minus u square divided by 2 plus u minus ln u minus u plus 1 plus c, the final answer of the solution. Another nice result, first is better to use substitution rule. Let's say e to the power t exponential function is equal to u. So this integral becomes u. So in this case, e to the power t dt becomes du. Okay, so e to the power t dt is du. You have du divided by e to the power 2t, means you have u square plus 3u plus 2. And as you see, it's a rational function, and the degree of numerator is smaller than degree of denominator. In this case, you find a decomposition for the rational function using the same idea. So this integral, if you find a decomposition, you will get this function 1 over x plus 1 minus 1 over x plus 2. Of course u, not x. U plus 1, u plus 2. So dt, of course, dt, du. Okay, and this is equal to ln u plus 1 divided by using the properties of logarithm plus c, and finally if you use back substitution you have ln instead of u, you have e to the power t exponential function plus 1 exponential function plus 2 plus a constant c. So it's all. And finally let me slightly change the question. Instead of sine q, let me write cosine q dq. Okay. Again, I first use substitution rule to solve the integral. Let's say sine q is equal to u, then cosine q dq becomes du. So this integral becomes, instead of cosine q dq, I have du. Instead of sine square q, I have u square plus u minus 2. So this integral, as you see, degree of denominator is greater than, bigger than degree of numerator. You have to find the decomposition for the rational function. So if you find, you will see that this is equal to 1 over 3, the integral minus 1 divided by u plus 2 plus 1 over u minus 1 du. Okay. So it's very easy to solve this integral. 1 over 3 ln using properties of logarithm u minus 1 u plus 2, and using the back substitution we have 1 over 3 ln sine q minus 1 divided by sine q plus 2 plus a constant c. So it's all for the time being.